Hello all, welcome back to our channel. Today we are gonna start an important topic from digital communications, which is sampling and aliasing. Sampling is the process of converting a continuous time analog signal into a discrete time signal. In simple words, instead of recording the entire signal, we only take values at fixed intervals called samples. Sampling is the very first step in converting analog information into digital form, which is required for modern electronic devices. The sampling theorem tells us the minimum sampling rate required for perfect reconstruction of the original signal. According to the theorem, the sampling frequency must be at least twice the highest frequency present in the signal. This minimum sampling rate is called the Nyquist rate. If this condition is met, we can accurately reconstruct the original analog signal from the samples. To understand Nyquist rate better, let's look at few examples. If a signal has a maximum frequency of 4 kHz, the minimum sampling frequency must be 8 kHz. In telephone systems, human voice has a bandwidth of around 3.4 kHz. That's why telephony systems use an 8 kHz sampling rate. Always include examples like this for better understanding. When we sample between the Nyquist rate, a distortion called aliasing occurs. Aliasing happens when higher frequency components of the signal appears as lower frequency compounds after sampling. As a result, the reconstructed signal looks completely different from the original. To avoid aliasing, we take two important steps. First, we use an anti-aliasing filter before sampling. This filter removes high frequency components that may cause distortion. Second, we sample the signal at or above the Nyquist rate. Both points must be included. There are three major types of sampling used in communication systems: ideal sampling, natural sampling, and flat top samplings. Each of these sampling methods are used for different practical purposes. Let's look at each one briefly. In ideal sampling, samples are taken as very narrow impulses. This method is not practical in real systems but is extremely useful for theoretical analysis and understanding sampling mathematically. In natural samplings, the top part of sample follows the shape of original analog signal. This method is closer to real world behavior, making it more realistic compared to the ideal sampling. In flat top sampling, the top of each pulse is flat, meaning it does not follow the exact shape of the analog signal. This method is used in PCM systems because flatter pulses are easier to convert into binary values. Waveforms for all three sampling types are important. After sampling, we reconstruct the original signal using a low pass filter. This reconstruction is only possible when the sampling theorem conditions are satisfied. So, accurate reconstruction depends on proper sampling. Thanks for watching the video. Do like, share, and subscribe.